All right, here we go, guys. So I guess what I want to do is, for the most part, good morning, all my homeschool people. All right. Today we're just going to go over this, and then tomorrow we have our quiz. If you do a good job on this and you understand everything, then you will be perfectly fine for the quiz. All right, so let's review. Let's go up. Anybody have any trouble with the true and false as you were looking through them? 11 is a really good one. Most people thought that was true. Yes. Anything with the true and false on 1 through 18? Yes, sir.
Yeah, number 4. I put true.
A plane contains at least 2. A plane is not defined with just 2 points. In order to define a plane, you need 3 non-collinear points. You with me? A line contains at least 2 points. All right? Should be 3. Yes. There's your counterexample right there, kiddo. You assumed that it was a segment. You see what I'm saying, right? That's a good one. All right, anybody else on the true and false? Anybody else on the true and false? And like I said, I did post the solutions for you. So 15. If a line is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. You see what I'm saying? Well, it could be like this. Now here, I think this really helped me out on these was thinking about 3-dimensional figures. Right, think about 3-dimensional figures. So if we were to draw, for example, a box real quick. I don't know if I could just take me a second. So if I were to draw a box, come on, hurry up. All right, so there's a good box, right? So the question is saying, if a line is perpendicular to one of 2 parallel lines. So I'm trying to demonstrate here how you can have parallel lines, for example, and not be that is perpendicular to the other. If a line is perpendicular to one of 2 parallel lines, now I'm trying to figure out how I'm going to show you this. Okay, so this right here, let me draw this. This is perpendicular. Oh my gosh, today's going to be a bad day. That's perpendicular, right? Now, this line right here is parallel to this line right here. You see that now? But it's not perpendicular to the other one. You agree? All right, so again, to me, the visualization, 3D is always helpful in my opinion. Go.
Number 7.
7. It's not a segment, it's a line.
Okay.
Right, that's the problem. All right. Anybody else at home interested in me explaining a true and false question? Again, most of the time it's just visualizing. Okay. Yes.
Number 13.
13. If 2 lines do not intersect, then they are parallel. Right. That's the skew thing people were asking me about yesterday. All right. Skew lines are, and normally you would say if 2 lines don't intersect, they are parallel, right? But you're not thinking in 3 dimensions. You see what I'm saying? All right. Yes, sir.
Number 18.
Number 18, 2 lines are perpendicular if their slopes are reciprocals. Now, if you remember from Algebra 1, the slopes are negative reciprocals. True? You can't draw perpendicular lines without their slopes being one positive, one negative, unless you drew them horizontal and vertical. But then one is undefined. Okay? These 17 and 18 were questions for next week, though. All right. Last year, I just gave one test on chapter 2. This year, I'm breaking it up. All right. So I'm not really concerned about 17 and 18. All right. Anybody else? My homeschool people, you guys all good? All right. Here we go. Let's look at this guy right here. Anybody have any question with that?
M.
Which one?
M. Angle M.
Angle M?
Yes.
Well, this is angle M right here, so it's supplementary to 75. So that's just
Okay, thank you.
right. Yes. Let's look at where is C. Okay, so now what I would like for everybody to do right now is just let me do this real quick for you. Let me pull this. Oh, I can't. This is a copy. All right. So listen. So as soon as I know this angle right here is 64, you should be able to tell me all of these angles, right? Because they are parallel. You agree with that? For this alternate interior, vertical, all that. This, I would feel better if you just put 116 here also. Now I'm just going to slide down here a little bit. All right. Now, I don't know anything about these guys right now because it has nothing to do with these guys over here. All right. So now I'm going to come down here. Now, the hard part I felt in this problem was doing this, guys. And on your test, if this were to happen, I would almost tell you that you should try to draw them out so you can see what those are parallel. Then look right here, guys. That's parallel, and that's parallel. So all 4 of those lines are parallel. That's why it was hard to see if you didn't pay attention. Because now look, all of these angles right here are corresponding angles. Everybody with me on that? Yes, sir. Yeah, well, I'm not there yet. Just give me a second. Let's look at that. I need you to, does everybody agree with that? So now, what am I telling you? Once I know that that's 108 degrees, look right here, please. Once I know that's 108, this is 108, this is 108, this is 108. Everybody agree with that? Which means now I know all 4 angles. That's 72, that's 108, that's 72. And if I want, I could just walk you down 108, 72, 72, 108, 72, 72. Does everybody see that? So I just wiped out that whole side pretty much. Now, when I'm doing these problems, I don't go in alphabetical order. I just go to things I know are true and start filling in. Now, I'm trying to find something else now. So really, now I can look down here and I can say, if this is 61 degrees here, this is supplementary. And if I wanted to, I could make this 61 and that 109. Does everybody agree with that? What? That's what I said, 119. Oh, so that's what you guys were telling me. That one's wrong. You're right. Yeah, I need to fix that. No, that's one of my kids last year did that. All right. That was 119. All right, is everybody good now? Thank you, guys.
How'd you get 116 for the school?
Well, I'm not
Alternate.
over there yet. I'm not over there yet. All right. But let's just look right here real quick. So we could, if we want to, put 169, and then that would be what? 11? And that would be 11, right? Okay. So now you have to understand this. I'm going to try to erase that. This transversal right here, stay with me now. This transversal right here now, the only thing I know, well, we did the 116/64 for all of those. Now, this right here and this right here, those are corresponding angles. You see that? It's very difficult to see because that other line is in the way. Do you agree? That's why it's hard. All right. Now,
Then,
go ahead.
then what about M?
M is an easy one because it's right next to 75 degrees.
Oh, it's on the top of that.
This right here is supplementary to that right there. Now, if you thought M was this angle right here, then it would be 180 minus 116, and I don't really care. All right?
Okay.
I think that knocked everything out, guys. Do you agree? All right, just fix that 119, please. Fix that 119. All right, now, I don't think 21 and 20 are that hard, right? Yes. 21. So all three lines are parallel, right? So to me, this angle and this angle add up to 180. You agree with that? Now, one way I tell kids to remember it is this is acute, this angle is acute, and this angle is obtuse. So that's an easy way. If not, you could just come over here and say this is 3y, which is kind of bad. Hold on. You can just say this is 3y. And then those are consecutive interior angles, so they add up to 180. And then these two angles are corresponding, so you set them equal to each other once you figure out what y is. All right? Okay, so here we go. Let's flip through these proofs. Is 22 okay, guys? And remember, I really don't recommend you just writing in the answers, right? I need you to ask me if you weren't sure about something. Sam. So here's BC.
Oh, yeah.
See it now? All right. Any questions with 22? Yes. Go ahead, William.
How did you get on mine? C is instead of M. I got substitution for that. How does C?
Definition of midpoint? Is that what you're asking me, William?
Yeah.
You want C to be substitution?
I got the wrong thing. I think I did.
You got it? All right.
Yeah, Mr. Stroud.
Yeah.
So on mine, the definition of midpoint on C was like blotted out or something. So I just did sap. And then for D, I had transitive.
Well, no, I think I just copied that in there. Why is AB equal to BC, guys? It's telling you right here, B is the midpoint of AC. Just because the segment addition postulate can be used doesn't mean the individual pieces aren't the same. Segment addition postulate tells you that AB plus BC equals AC. The midpoint tells you that AB is equal to BC. E is the midpoint of DF. That tells you that these two are equal. You agree with that, Harris?
Yeah.
Anybody else on that particular question, number 22? Not too bad. Not too bad. 23. Q is the midpoint of PR. PQ is equal to QR. Kind of the same thing almost. Yes, we're not going to talk about that anymore. Transitive property and substitution. Doesn't matter to me. What? Why is PQ equal to QR? What? You see that?
Yeah, I was on the one.
Pretty good, guys. 23. I don't think that's too bad. Bless. All right, here we go. Let's check out 24. So this one was a little annoying, but kind of not too bad. Let's see what this says. ABC and CBD are complementary. So let's highlight that. ABC and CBD, these two, these two angles right here are complementary. And then it says that DBE and CBD. Okay, so this is kind of like, all right, those two things. And we're going to prove that ABC is congruent to DBE. Now, because it tells you that they're right angle, that means they are what? They're complementary. I'm going to say it right now. So now, why is ABC congruent to DBE? Now, I'm just saying that angles that are complementary to the same angle, they are what? They are congruent. All right? Angles complementary to the same angle are congruent. So let's give an explanation of that, just visually so you can see. Let's say this was 70 degrees right here. Then ABC would have to be what? 20. And then what? DBE would also have to be what? And it has to be 20 because 90 degrees and complementary. So if two angles are complementary, or I'm sorry, If two angles are complementary to the same angle, then those angles are congruent. Yes, sir. What? But we're not substituting. There's nothing that says they're congruent. You see what I'm saying, right? I'm not replacing, like, nothing up here talks about, nothing up there talks about congruence. You see what I mean? So my question is, what are you replacing? That's my question. Like, a substitution just means you're substituting one thing in for the other. We have not stated anywhere that two things are congruent. You see what I'm trying to say? You sure? Right. So remember, the substitution would have to be just replacing one part of one statement with another part. You with me on that? It's completely changed here. There's just a theorem that says if two angles are complementary to the same angle, then those two angles have to be congruent. All right. And the same thing with supplementary. If two angles are supplementary to the same angle, then those two angles have to be congruent. Yes, Drew. What is the comp? I mean, and I'm not arguing with you, but I just thought complementary. If two angles add up to 90, then they're complementary, right? Isn't that the definition?
Yeah.
Right. You see what I'm saying? Yeah. Right. And to be honest, you know, those are little minor details, right? I would just want you to say its definition of complementary. Yes.
The definition of complementary is the same thing as the definition
Yeah. Definition of a right angle is the measure is 90 degrees, right? These A, D, B, E, and C, B, D form a right angle. Therefore, they are complementary. Right?
Yeah.
That's what complementary means. Two angles that add up to 90 degrees. I don't know what you mean, would they be the same thing? So, I can have a right angle without it being complementary to anything. True? Like two perpendicular lines form a right angle, right? We don't say they're complementary. You understand what I'm trying to say. Now, I'm just trying to help you with the details, that's all, right? So I can draw a right angle.
Oh, yeah.
You see what I'm saying? I can draw a right angle, just one angle. But complementary, you need two angles. All right. Hopefully I'm helping. All right. I understand it's frustrating, okay? Just the little details. All right, let's look at 25. What are we thinking on this?
What is like, what is RC?
What is what?
What is RC?
Yeah, ABC is a right angle. Right, RT, I just put right.
Oh.
Sorry about that. Right, it's a right angle. Remember, if two lines are perpendicular, they form what? Right angles. And here we are again down here. Angles complementary to the same angle are congruent. There's other ways of doing that too. So again, remember, I have to follow your logic on your test. If you have it a little bit different, I'm okay. That's why sometimes I prefer not to have the listed out for me. I prefer to do it myself. What? because I said that ABC is equal to the measure of angle 1 plus the measure of angle 2. Now, what do you think it would be?
I did
Okay, so now do you understand what I'm saying, right? It's like the segment addition postulate, right? It's just saying the parts add up to the whole, all right? And once you do that, then you can do some substitution and then you can see it. Yes, William.
For H, I did substitution.
Okay, so remember now, guys, the problem I'm having, this is what I was trying to tell Simon. A substitution is putting 1 directly in for something else. Show me where there's a congruent statement up here that you're substituting in. No, I'm asking. Hold on, you can tell me in a minute. I'm trying to get him to see. William, what? Right. Exactly. But now, Drew, you tell me something. Go.
Yeah, I think the game stuff like that, controlling the favorite complementary, in 1 and 3, but that doesn't have to mean.
Yes, right. That's what I'm trying to say. We would, and again, I'm glad you're saying, or you're seeing that now, and hopefully, Simon, you understand me better now on another example, right? There is no congruent statement anywhere, so I'm not substituting anything in, right? Hopefully you understand. All right, go ahead. Surprise, surprise, surprise. All right, guys, this is the first time, so even if it's fill in, it doesn't matter. We're not stressing over the test. All right, your stress comes from doing what we're doing right now, making sure you're asking questions so you understand a little better. All right, I know geometry is tricky, this part. All right, don't worry. All right, what's troubling if I give you a proof and just leave it completely blank? That's troubling. All right, write something down. Try. You're not going to get better until you try to write something down. And then the other thing I'm saying, guys, if you don't know, like he was asking me, is that a theorem? Or if you don't know, that's what I'm saying. You can just look things up, right? Just look it up. What's a right angle? What's the definition of right angle? And it'll tell you, okay? Whether it's a theorem or a definition or whatever. All right, up here, this one's nice. All right, especially because I haven't really talked about this so much and I wouldn't even care. That's why I'm telling you guys, please listen to me. The converse of the alternate interior angle theorem. I don't really expect you to know that, right? I would just say that what? That because angle 2 is congruent to angle 3, those are what? Alternate interior angles. So I would say if alternate interior angles are congruent, then the lines are what? Parallel. The original theorem was if lines are parallel, then the alternate interior angles are congruent. Everybody with me? So is the converse true? Yes, the converse is true. If the interior angles are congruent, then the lines must be what? Must be parallel. Do you have to know it's a converse? No. You can just write on the test. The alternate interior angles are what? Congruent. Therefore, the lines are parallel. If you want to write converse of alternate interior angle theorem, man, that sounds even good too, but I don't care. I don't care if you know if it's a converse or not. All right. Originally, we said if the lines are parallel, then this is true. Now we're saying the converse. If the alternate interior angles are congruent, then the lines are parallel. All right. Does anybody have any issues with that? Any issues? All right. Number 27. Let's look at this one. This one's kind of nice. All right. Now here we're trying to prove 2 things, okay? We're trying to prove 2 things are true. Now, obviously, number 1 is given. Why is 13 congruent to 15? They're what? Vertical angles. Why is angle 5 congruent to angle 13? That is a substitution. Now, why is R parallel to S? Why is R parallel to S? Because we have what? These are what? Corresponding angles. That is a what, though? Is that a theorem or a postulate? The one that is the postulate is the corresponding angles. That'd be kind of good to know, but I don't even care about that either. All right, because it doesn't make sense. You prove all the other angles are congruent by using a postulate. All right, but it's just good to know. Corresponding angle postulates, the other alternate interior angle theorem, alternate exterior angle theorem, consecutive interior angle theorem. Those are the theorems. All right. Now, again, is it necessary to say converse of the corresponding angle postulate? No, you can just say, what can I say? 5 and 13. Corresponding angles are congruent, therefore the lines are what? Parallel. I'm totally happy with that. All right. Olivia, I'm sorry. Go. Good, good. Thank you. All right. So we just proved R and S, right? And now, what's true about 1 and 5? So if I look at 1 and 5, those are also what? Corresponding angles to L and M. Same thing. Morty. If corresponding angles are congruent, then the lines are parallel. That's what that says. You with me on that? Right? If alternate interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, the lines are parallel. If consecutive interior angles are supplementary, the lines are parallel. Those are all the rules that you should know. Yes, ma'am. Yes, top left, top right, bottom left, bottom right. That's how I describe it. So look right here. So this is the top left. This is the top left. Does that make sense now? Yes. Right. 1 is corresponding to 5. 1 also corresponds to 9. 5 also corresponds to 13. You agree with that? But 9 is not corresponding to 5. True? They're all congruent, but they're not corresponding. Right? And then, just to make sure, 2 corresponds to what? 10. 10 corresponds to, and 14 corresponds to, and so on. Agreed? All right, go. That's not what the definition of parallel lines are. Yeah, some of you guys now, you got to listen to what I'm saying. All right, the definition of parallel lines are just lines in the same plane that do not intersect. True? That has nothing to do with alternate interior, alternate exterior corresponding. You with me? All right. All right, let's move ahead. Guys, are these kind of easy, right? That's just algebra, right? Anybody need me to do 28, 29, 30, 31? Anybody? Straightforward, right? 32, 33, and I just wrote out the answer for 34 for you. Anybody? Anybody want to talk about something? 32, 33, 34? Yes, good. Actually, what? 32. Let's knock out 32. All right, sorry, mine's a little blurry. All right. These are parallel, correct? So this angle right here is equal to this angle right here. You agree with that? Right, and then you have to think back to 6th grade. Right, the angles of a triangle always add up to 180. All right, and that's something we'll be proving in this class too. Somebody else? Everybody's feeling okay? All right, good. Yeah, that they're just more specific than I am, right? I just say if something is equal, it's congruent. That's just definition of congruent. All right, that's good. There's subtle differences, and I just want you to give it your best shot. All right, not worry. All right, it looks like that's it for the review. You guys now just please practice. I normally I'm just going to tell you this right up front. Some of them might be exactly the same. The proofs might be exactly the same. That's how I do it. All right. You have to practice. Now, sometimes what I do is I white out everything instead of giving you hints. I just cross everything out, and you have to fill the proof in. All right. Sometimes I do fill-ins. Sometimes I do where you just do periodically some on some on the other. All right. What? I think that's a pretty good question. I'm kind of proud of you. I would say it would be good to review. All right, it would be good to review what that means. All right, very good, Bo, actually. All right, so
What means?
Bo asked me a question. In this chapter, we discussed converse, inverse, contrapositive, biconditional, and I would just say you should review that. All right, I didn't put an example. All right, I was going to surprise you. That was going to be my quiz surprise, okay? But Bo was smart enough to ask me about it, so I'm not going to tell a lie. So review that. All right, my homeschoolers, how are you guys doing? Okay, you guys got any questions? All right, we will now just close and you just get back to studying, okay? Just review your notes. I promise you, it's not going to be a big deal. All right, have a great rest of your day, guys, okay?
Bye. Thank you.
I'm going to post it.
Thank you.
Thank you.
Bye.
Thank you.
You're welcome. You're welcome.